Okay, so what we've done is we've taken any acute triangle. Remember, when we're talking about acute triangles, we're talking about all angles in this triangle are less than 90 degrees. Okay, so we've taken an acute triangle and we've drawn in the height. Okay, so there's nothing special about this triangle. We don't have any dimensions yet. It works for any generic acute triangle. Okay, the next thing we do is that we're going to solve for h using our trigonometry or our SOHCAHTOA, our trigonometric ratios. So if we focus on the triangle AXC, so AXC, so this triangle here, here's our right angle, here's our triangle. We know that sine A, opposite this angle, is h over b, okay? So therefore, we can multiply both sides by b. These cross out, and we get h is equal to b sine A. Any questions about this? How we found that? Okay.
Pardon me, would Tony Zhang please come to the main office? Tony Zhang.
The next thing we do is we focus on the other triangle that we created, BXC, and we do the same thing. Sine B is equal to h over A now. A is the hypotenuse. Okay, so we develop this equation, exact same way. Next, we set the two equations equal to each other. So this is h, so b sine A is equal to a sine A. So we're pretty much already there. Now the last step is we just simplify. So dividing both sides by sine A, these cross out, and we end up with this formula. Okay? Any questions about that? All right. So this process can be repeated for a different altitude. So in this time we can draw our h value in here and do the same process, and we find that for all three sides and all three angles we can develop this formula. Okay? Yeah. Oh, thanks. Okay, so here's that same triangle, but we're just defining h as a different altitude here. Okay, doing the exact same process, and what we figure out is that all of these ratios end up being the same. So there's the proof, okay? So if I put on your test, prove the sine law, show me proof for the sine law. Really, the only thing that you have to memorize, I would hope, is a triangle ABC and draw in the height. And then just find your sine values of either angle. So sine A is equal to h over right? Sine B is equal to h over y. Okay, and then you equate the h values, so h is equal to x sine A, h is equal to y sine B. Set these two equal, and then rearrange. Okay, this should have been, this should have been A in the original triangle, and this should have been B. Right, because it's opposite B, small b, opposite A, small a. Okay? So really, if I say prove the sine law, you should remember how to draw this triangle and solve for the height. And then equate them. Because I think once you have this, right, going from here to here is simple, just multiplying and crossing out until you're there. Okay? Multiplying by sine A, make your cancellations, you get that value. Any questions? All right, so we've proved the sine law both algebraically as well as through trial and error using a ruler and a protractor. So now we're going to use it for some examples. Stephen?
Read.
Yeah.
Example 1. Find the side length using the sine law. A bicycle path forms a 66-degree angle with one of the locks of the canal. At a distance of 2.5 kilometers along the bike path, the angles separating this lock from the next lock is 50 degrees. How far apart are the two locks to the nearest tenth of a kilometer?
Okay, good. So we have this triangle here that's created by the two locks here. We have this triangle. We're given a lot of information about it. We're given this angle, we're given this angle, we're given this distance. Can we find out this angle now? What do you guys think? Kevin, do we know what this angle is? If we know this angle and this angle,
Yes.
what's this angle? What is it?
190 minus 66 and 52.
Yeah, he meant 180.
180, sorry.
Yeah. So what's that? Okay, so if we needed it, we have it. I don't know if we're going to need it with our sine law. I don't think we will, but in any event, we could have found it. It asks for how far apart are the two locks to the nearest tenth of a kilometer. So Joseph, what are we asking for here? What dimension? How far apart are the two locks? So what dimension? Sorry?
P.
Yeah, P, good, little p here. All right. So before we can use the sine law to find the length, we need to find the measure of angle K. We do need it actually. So we found the measure of K, which is 62. We know that. We now apply the sine law. The reason why we needed K is because we had information about the opposing side to K. That's why we needed to find K. If we had information over here, the opposite of angle L, we wouldn't have needed to find K. Okay? Because we have the information about the opposing side to K, we needed to find the angle K. Once we find that angle, we can create our equation. Again, because we're solving for the side length, we put the side length on top, P on top, over sine capital P, sub in our values, and solve for P, 2.2. Okay? Pretty straightforward. Any questions? All right. Carlson?
You can also use the sine law to find an unknown angle if you know two sides and an angle opposite one of the known sides. Sometimes the sine law appears in a different form. Recall the result obtained earlier for triangle ABC.
Okay, so this is the form that I mentioned to you, the reciprocal. Okay, so sometimes it can appear like this. And we use this again when we're solving for an angle. It's asking for an angle, so we're going to flip them and look for using this equation. So here's our sine law when we're searching for angles. Either form can be used to find a missing side or angle. This alternative form is a little easier to use when finding an unknown angle. So if you only memorize one, it's fine. Doesn't mean you still can't solve for either an angle or a side. This just makes it quite a bit easier and faster. If you can remember when you're solving for an angle, you put the angles on top. All right, let's see example 2. An acute triangle TUV, TU is 11.1, UV is 5.8, and angle T is 31. So given this information, we have to understand how triangles are labeled. So the angle T and side TU, we have to know how they relate because we're not going to have this triangle drawn. So we need to be able to take this information and draw a triangle accurately based on this information. If we don't know that small t is opposite large T, angle large T, you might draw this triangle wrong. Okay, and if you draw it wrong, then you're going to get the wrong answer. So it's important to note when we draw this TUV, we have to say that UV is 5.8. This side UV has to be opposite angle T. So if you drew this the other way around, it could be drawn wrong. Okay, so it's important that the nomenclature and the way they're given, actually, I'm not sure you could have messed this up because they use the two vertices to describe it. So I think even if you drew it the other way, UV and VU would have been the same. But if they gave you the length, such as, you know, T is equal to 5.8, you need to know where that T goes. It goes opposite big angle T. Okay? That's my only point. I'm stressing that because a lot of students will make that mistake. So we draw a diagram and label the given information. So here's our triangle, and it wants for angle V. So here's angle V up here. We have information now about T and its opposing angle. So of the three equations in the sine law, or the three constants, I'm going to need to have T as one of them. I'm going to put sine T over T as one of the three. Okay, remember, any problem you do for sine law, you're only going to use two. Of these three, you're only going to use two. You're either going to use sine A over A equals sine B over B, or sine A over A equals sine C over C, or sine B over B equals sine C over C. You're only going to equate two. Never need to equate all three in any problem. It's the choice, which two do you choose? You have to choose the one that you're looking for. So in this case, it asks us to find V, so I'm going to have to choose these two because it's asking for angle V. The other one that I choose is going to be based onto what's given in the information. Because they give me angle T on the opposing side, I'm going to equate it to these two. I'm not going to use U at all because I don't know anything about angle U or side U. Does that make sense? All right, so I put sine T over T is going to be equal to sine V over V, which is 11.1, and T is 5.8. Okay, and now we solve this. T here is 31. Okay, to solve this for sine V, it's just going to be this times 11.1. So 11.1 sine 31 over 5.8. Okay, all of that in your calculator will give you a value, a decimal value. And then you're going to take, to solve for the angle V, you're going to take the sine inverse of that value. Okay, and that should be done here. So here it is. We plug in our values. Sine V is equal to this. We get the value of sine V, which is 0.9856. We take the sine inverse of that value and we get 80 degrees for V. Always a good practice to go back, look at the angle. Does the angle of 80 degrees make sense here? Yes, it does. Okay? You listening, Michael? All right. Example number 3. Back to Bermuda Triangle. Last one. David.
Use the information given on the diagram to determine the perimeter of the Bermuda Triangle to the nearest 100th kilometer.
Okay, so it's asking for the perimeter. So what does that mean? What do we need to get the perimeter? Yeah, Daniel. Yeah, we need all three side lengths. So what is this side length called, Nicholas? What variable would I use for this? Yeah, what letter?
Oh, M. Lowercase m.
Yes, good. Lowercase m. And over here? What variable or lowercase am I going to use over here?
Lowercase s.
Good, s. Okay. So we need to solve for lowercase s and lowercase m. We're given information about two angles and a side. We need to find out this angle. Why do we need to find out this angle? Michael?
Sure, because they give you the side that's opposite of
Excellent, very good. So what is this angle, Michael?
50 plus 74, and whatever that is, subtract from 180.
Yeah, I was hoping to get an answer, but yeah, 56, right?
Yeah.
Sure. All right, 56. Okay, so we have this angle, 56. We have this side. So whatever one I'm going to solve for, either S or M, I'm going to use these two pieces of information. So I'm going to definitely use the B side ratio, side to angle ratio. And then I can use solve for either S or M first. Okay? Here they solve for M first. So because we're solving for a side length, we put the side length on the numerator. So lowercase m over sine m is equal to b over sine b. We have all this information, 50, 1600, and 56. It all comes from the triangle. And we just solve for m. Okay, m, remember cross multiply, sine comes up here. Sine 50, 1600 over sine 56. Any questions? All right, that's m. Next method we do, we're going to solve for lowercase s. So they set up their equation, they put in their knowns, and they solve for s. So finally, the perimeter, they add b, m, and s. There's your final perimeter. Question about the last one? No? All right, key concepts. Your formula, when you're looking for angles, when you're looking for sides, here, this is to solve for sides. And finally, the sine law can be used to find an unknown side if two angles and a side are known, an unknown angle if two sides and the angle opposite one of the known sides are known. Okay, so that's self-explanatory what's given in the problem. That'll allow us to solve using the sine law. Any questions?